Hi everyone, welcome to your geometry weekly recording. It is the week of January 30th and we're also working in the week 4 folder. So far in second semester in unit 5, we've been looking at solving right triangles. We've learned a couple different ways that we can solve for right triangles. One way is if you have two sides that are labeled with lengths and it's a right triangle and you're trying to find that third side length, you can use the Pythagorean theorem. Then we also looked at similar right triangles where we drew in an altitude for a right triangle and we used geometric means to find the lengths of missing sides of those similar right triangles. Then we learned that when we're given some angle measurements such as 45 degrees, we can use special right triangle patterns, the 45, 45, 90. We looked at the special patterns that occur for the side lengths when we have labeled sides for 30, 60, 90 triangles. And then we started getting into some trig ratios that you can use when you've got right triangles to find missing side lengths. Well then, last week we started looking at how we can use side lengths to help us find missing angle measurements. And remember, anytime we set up a trig ratio or trig ratio, whether it's sine, cosine, or tangent, we always put the angle measurement next to the trig ratio. So we're always taking the trig function times the angle measurement. So that's always what, and then we would always set it equal to the legs, like opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. So this piece right here, right next to the trig ratio, always has to be the angle measurement. So we're going to start with a warm-up problem. Notice where it says sine x equals 0.5. So this x right here is representing an angle measurement. We learned this last week, that there's a special way that we solve for x when we're trying to find the angle measurement. So when x is being multiplied by sine, cosine, or tangent, that means we're trying to find the angle measurement. So go ahead and take a moment and try this warm-up problem on your own. And then when you're ready to check your work with mine, go ahead and click play. All right, so whenever we're trying to find an angle measurement, and again, that's when you've got a variable that's being multiplied by sine, cosine, tangent, the variable's right next to that trig function there. So whenever we're trying to find a variable that is being multiplied by the trig function, we're trying to find the angle measurement, right? We're trying to find the angle measurement. And when we're trying to find the angle measurement, we have to use the inverse function to allow us to find that measure. So the reason why is essentially we're dividing sine out of each side, right? Essentially we're dividing sine out of each side to get x alone. So remember, whenever we have something in our denominator, it's really the same thing if we move it to our, if we were to move sine to the numerator, then it would be the inverse of sine. It would be as if we were to take that exponent and raise it to the -1 power. And that's, remember, we learned that in algebra last year, the rules of our exponents, and when we move exponents back and forth on our numerator and our denominator. So if like we had x squared and I moved it to my denominator, it would become -x squared. If I have x to the, I'm going to stop there before I get in a whole algebra lesson. So that's what we need to do, is that's the reason why anytime we're trying to find an angle measurement, that's the reason why we take the inverse of the trig function. So anytime you're trying to find an angle measurement, you're going to use the trig function inverse. So that means we're going to take the sine to the -1 power, that's the inverse, times 0.5. And you just plug it into our calculator and let the calculator do the work. So to do that, make sure that you're not just typing in sine in your calculator. A lot of times, like if you're using a scientific calculator, you're going to have a key that says second. So you're going to hit the second key. And then you're going to hit the sine, the normal sine key. And if you look above that, you'll see that what you're doing is accessing, that allows you to access the inverse of the sine. So doing that and then plugging in that 0.5. So the inverse sine of 0.5 gives me, when I plug it into my calculator, 30. And I know that that represents the angle measurement. So that angle measurement would be 30 degrees. So remember, when we're trying to find a missing angle measurement using a trig function, you have to use the inverse. So I'm going to go on to the next slide. So if you need more time here, go ahead and click pause. All right, so this week, you're going to do a grade check assignment. Then we're going to do a lot of review on Unit 5. So we're starting to wrap up Unit 5 and all about solving right triangles and triangles. So we're going to do some review this week and also review with a Unit 5 project that it combines all the concepts that we've learned so far and different ways and methods that we can solve for missing sides and missing angle measurements of right triangles. So just some reminders, make sure you're checking your grades often, and remember, if you turn in late work or redo assignments, you have to send me an email, and then please be patient when you submit late or redo assignments. My priority is always to grade the assignments that are turned in on time first, and then I start going back and grading redos and late work. So I will get to it, just be patient with me. Thank you. All right, so some things to remember as we're wrapping up Unit 5. Your calculators, make sure that you're in the degrees mode when you're using those trig functions. SOHCAHTOA is a great way to remember the different trig ratios and which goes on top. So first, the sine ratio, it's going to be the opposite side over the hypotenuse. For the cosine function, it's the adjacent over the hypotenuse. For the tangent, it's the opposite side over the adjacent. So these are just some great ways to remember those ratios. And then, just like we did in the warm-up, just remember when you're trying to find an angle measurement of a right triangle, to use the inverse of the trig function, That's how you find an angle measurement. All right, so moving on to the next slide, let's do some review as we're getting ready to tie up the Unit 5. All about right triangles. Let's do some review. So here I've got a right triangle. Both of these are right triangles, and we're given one angle measurement right here, and we need to find this missing side here. We're given one side length, and we need to find the other one. So we cannot use the Pythagorean theorem, because in order to use the Pythagorean theorem, we would have to know 2 out of our 3 sides. So right away I know, okay, I can't use the Pythagorean theorem. So we learn that we can use trig ratios when we're given an angle measurement and a side length. So whenever we're given a side length and an angle measurement, we can use a trig ratio. So which trig ratio are we going to use? Are we going to use sine, cosine, or tangent? So I always like to put up SOHCAHTOA so that I can look at those and help me figure out which one I'm going to use. So since we're given this angle measurement, I'm going to use this as my reference point. So pretend we're standing at the corner of this angle. And which sides are we given? Well, this side over here is the opposite side. This side right here that we're trying to solve for is the adjacent side. And then the hypotenuse is always opposite the right angle. So the hypotenuse will always be opposite the right angle. We don't need the hypotenuse here. It's not going to help us in any way. So I'm not even going to label it because it's not going to help us. I don't want to distract us. So the 2 sides that are helping us are the opposite and the adjacent. So looking up here, SOHCAHTOA, that tells me I'm going to use the tangent because I have the opposite and the adjacent. So I start with writing my ratio. So I always write tangent. Remember, you always write tangent times the angle measurement equals, and then it's the opposite side over the adjacent side. TOA. So we need to solve for x, and right now x is in our denominator. That's not a good thing. We need to move it to I'm sorry, not the denominator, that's where it is. We need to move it to the numerator. So what I'm going to do to move that to the numerator is I'm going to multiply this side times x, because then our x's cancel out on the left. Whatever I do to one side of my equation, I have to do to the other. So I'm going to multiply x on the left side. So now I've got x times tangent 51 equals 46. And so right now x is being multiplied by tangent 21. So the opposite of multiplying is dividing. So to solve for x, I'm going to divide each side by tangent 51. And what do I get? I'm going to let my calculator do the work. I'm going to type into my calculator 46 divided by tangent 51. And when I do that, I'm going to round to 2 decimal places. I get 37.25 when I round to 2 decimal places. Oops. So that is this side length here. It's going to be 37.25. Now, if you want to try number 2 on your own, so remember it's always nice to try some on your own to get some good practice, because I'm going to then go over the answer and you can check your work. So if you want to click pause now and try this one on your own, go ahead and do that. I'm going to choose a different color here. How about, let's do green. So now we're trying to find the angle measurement, right? We're given 2 sides of our triangle and we're trying to find the angle measurement. So can't use the Pythagorean theorem. Pythagorean theorem only finds the missing side length, and we're not looking for the missing side length. We're looking for the angle measurement. So we're going to use a trig ratio. So which 2 sides are we given in relation to this angle right here that we're trying to solve for? So opposite the right angle is the hypotenuse. So I know we've got the hypotenuse. We don't have the adjacent side. This side right here is the opposite. So we've got the opposite and the hypotenuse that can help us solve for the angle measurement. So that means we're going to use the sine. So remember, we always say sine x because it's the angle measurement always goes right next to the trig function we're using, and then opposite over hypotenuse. So remember, to find a missing angle measurement, we use the inverse of the sine function. So what we're going to type into our calculator is the inverse of the sine times 8/13. So go ahead and plug that in your calculator. So you'll hit the second sign to get that inverse, and then 8 divided by 13. And when I do that, I get 87 we'll go 2 decimal places, 98. And that's degrees because that's the angle measurement. This angle measurement right here is 87.98, so almost 88 degrees. All right, moving on to the next slide. So if you need more time, go ahead and click pause so you can take really good notes. All right, so 30, 60, 90 triangles. We get this general pattern that occurs between all of our side lengths. So it's really important that when we use this, that we are making sure that we are between the 60 and the 90 degrees. That's always going to be the hypotenuse, and that's represented by 2x. Between 60 and 90 degree angle, that side of the triangle is just x. And then between the 30 and the 90 is x times radical 3. So here, we are given the length of our hypotenuse, and we need to find the other 2 sides of this 30, 60, 90 triangle. So I know this is a 30, 60, 90 because I'm given one angle. You have to be given an angle measurement to know what the other angle measurements are. So this one's got to be 30 degrees. So we're given the hypotenuse. So remember, the hypotenuse is always represented by 2x. So we know that the hypotenuse is represented by 2x. So what I like to do is just set my equation 2x equals the given side, and then I'm going to solve for x, because once I know x, I can plug it into the other missing sides with that pattern, the patterns that occur. So divide each side by 2, and I get x equals 20. So that means that the side between the 30 and 90 degree angle has to be x radical 3. So I know x is 20, so the side between 30 and 90 is x radical 3, which means I plug in what I solve for x, to be 20, and then I know it's 20 times radical 3. So the side length of this side length here is going to be x times radical 3. The side length between the 60 and the 90 is just represented by x. And remember, we found x to be 20. So this side length here would just be 20. And that's it. That's how we use the patterns and one given side to then find all the other given side lengths or asked for side lengths. Moving on. So if you need more time, go ahead and click pause. All right, so law of cosines. We looked at this last week. So when do we use the law of cosines and sines? So we use the law of cosines and sines when we're trying to solve for missing side lengths or missing angles that are not right angle triangles. So far, everything that we have looked at, all of our methods that we've learned so far until we get to law of cosines and law of sines, were methods that we use to solve for right triangles. Well, now we need a method to use when we don't have a right triangle. And that's going to be the law of cosines and sines. So remember, we only use those when we're solving for non-right triangles. So the law of sines we use when we know two sides and an angle. So like here, we know two sides and an angle. We can use the law of sines. Or when you have two angles and you're one side. And you're trying to get the side opposite of one of your known angles. And then the other option is when you've got you're trying to find an angle opposite of one of your known sides. So you've got to have a set of knowns that are opposite of each other, like an angle and then an opposite side of that angle that both are labeled. And then if you've got a side and that side opposite, you're trying to find the angle, you're going to use the law of sines. Vice versa, again, if you have a set of opposite angle and sides that are known, and then you're trying to find a unknown side opposite to a known angle, you're going to use the law of sines. So what you're going to do is use a proportion to help you solve using the law of sines. You're only going to use two ratios. Remember, a ratio or a proportion is just two ratios equal to one another. So you're only going to use two of these three. You're not going to have two sets of equal sign. So look at an example here down below. And the ratios that we're going to use is that you're going to do the side length over the side length given to you over sine times your angle that is opposite to that. So look at here's side A. Opposite of side A is angle A. Side B right here, opposite of side B is angle B. And then last but not least, we've got angle C. Opposite of angle C is side C. So look to the opposites of one another to set up your ratios and proportions. So let's look at this example. So here I've got this angle 115 degrees, and opposite of that angle is the known side 49. So I'm going to write a ratio right off the bat. I'm going to say 49, my side length, over sine 115. I'm going to set that equal to, now I'm trying to, I've got this side here, and I'm trying to find that opposite to that side, that angle measurement. So then I'm going to set up another ratio, which is going to be that side length of 16, and then sine, we don't know. We're trying to find that angle measurement. So now I have a proportion set up, And I can solve for my unknown by cross multiplying. So I'm going to cross multiply and set up an equation where, here we go, let's cross multiply. So I'm going to take 16 times sine 115. I'm going to set that equal to 49 times sine x, and we're trying to solve for x. So 49 is being multiplied by all of this, right? So we want to work on getting sine all alone, so I'm just going to start by dividing each side by 49. And I'm going to let my calculator do all the work. So I'm going to type into my calculator 16 sine 115 divided by 49. And then I'm going to round, and I get, what do I get? 0.30 equals sine of x. So remember what we just talked about. We're trying to find an angle measurement because that x being multiplied after the sine, that means it's an angle measurement we're looking for. So therefore we have to use the inverse of the sine to solve this. So I'm going to plug into my calculator the inverse sine of 0.30. And what do I get? 0.55 when I round. And that doesn't make sense, so I'm looking at all the other, that this is 115 degrees. It doesn't make sense for this angle to be 0.55. So I'm going to recheck my work. I'm going to type in again. I think I might not have hit this, the inverse. So the inverse sine times 0.3 is actually 17.5. So that was an error, so I fixed that because it didn't make sense. So I knew I must have done something wrong. So that actually is going to give us 17.5 as that angle measurement. And that is how we use the law of sines. And just a reminder too, I wanted to do that example of what we do when we're trying to find an angle measurement. We always use the inverse of that trig function to find the angle measurement. So that's the last problem that I wanted to go over with you. I don't want this recording to get too long. So make sure you review law of cosines as well. That's all. So my key phrase assignment or question to you is, what do you use when you're trying to figure out a missing angle measurement or even a missing side length of a non-right triangle? So we've learned there's a bunch of methods that we can use when we're trying to find missing sides or missing angles of right triangles, but what methods can we use when we're trying to figure out a missing angle measurement or even a missing side length of a non-right triangle? So directions below if you need it to complete the key phrase assignment. Otherwise, have a fantastic rest of your week and let me know if I can help you with anything. Have a great rest of your week. Make sure you took good notes while you were watching this recording because you will need to turn those in.